Hello, it is Monday. We are finally in a new chapter. Praise God. And the chapter that we're on to now is going to be dealing with rational expressions. The first section is going to be multiplying and dividing the rational expressions. But before we get into that, we just need to go over some basics. Most of the work that we're going to be doing with the rational expressions is going to require us to be able to factor. So before we get into that, I just want to review um, four of the basic types of factoring that you'll see throughout Chapter 9. The first one is just if you have a basic GCF, and remember GCF is our greatest common factor. So what we would look for is we look for something that can come out. In this case, we have three terms. We look for something that can come out of all three terms. So for this example here, we can. It's ridiculous. I always yawn as soon as I start. So we can take a 3 out of all of these. That's a GCF for the number part. But remember that the GCF can also be a variable. So since they all have, take out the lowest exponent. So in this case, it would be x to the first power. So when we take that out, let me just move this down a little bit. So once we've established that we have a GCF, that goes on the outside. We put our parentheses, and then we divide each one of these terms by that 3x. And what's left is what goes in the parentheses. So 18x cubed divided by 3x squared is going to give us 6. Remember, when we divide, we subtract the exponents, so that'll be x squared. 9 divided by 3 is 3. It's a minus, so negative 3. And then again, we subtract the exponent, so it's just 3x. And then 24 divided by 3 is 8. And 1 minus 1, the x's are canceled. So this would be our factored answer. For the second answer, number 2, well, the second one here, with this 7 v to the 5th and 9 v to the 3rd, if we focus on the numbers, there's nothing that can come out of 9 and 7. 7 is prime besides, and 9 can't get 7 or 1. So we focus only on the variable, so we take out a v. Now, if you just take out v, that's incorrect. You're always going to take out whichever one is the lowest power. So we want to take out a v cubed. That'll be the GCF. Again, we want the greatest common factor. So we're dividing by the v cubed here. So it's still going to be 7, and it's going to end up being v squared minus 9, and then the v cubes will just cancel out. So this will be our answer. The next type of factoring is going to be very popular as well when we are simplifying and working with these rationals. And that's going to be when we have a trinomial, a here is 1. When a is 1, it basically just won't be there. It'll just look like, just the x squared part, just kind of ignoring the a totally. But when a is 1, basically what you do is you look for factors of c. We look for factors of c that give you b, that add to give you b. So in this case, this is a, this is b, this is c. C is the constant. All right, so we need, factors of negative 14 that are going to give you a positive 5. So factors of negative 14, for the first one here, I'll just list everything. It would be negative 1 and 14, negative 14 and 1. Remember, these are different options because this will give you 13, this will give you negative 13. So you need to list both. And then you have negative 2 and 7, or negative 7 and 2. That's it. This one would give us 5, and we add them up. This would give us negative 5. We need a positive 5, so the pair we would pick for factors would be this pair. So we would just write two binomials. It'll be x minus 2 and x plus 5. I'm sorry. Excuse me, x plus 7. Sorry. And that would be our answer. And if you went back and FOILed it, it would work out. For the next one, so we need factors of negative 10, because that's our c, that give us negative 9. So those factors are going to be negative 10 and 1. So our two binomials will be x minus 10, x plus 1. All right. The next type of factoring we will review because it is important just to review them all, but you won't see as many of these like C type of factoring. I'll probably throw, one or two in, excuse me, one or two in for each quiz, but it won't be like a predominant amount of the factoring. So when it comes, this is a little bit different. And these A is not one, so it'll be something like a 2 here, a 3 here, etc. So because it's not one, you have to take that A into consideration. So when A is not one, the way we are going to approach this is the first thing you're going to have to do is find AC. And I'm sorry, for all these factorings for B and for C, look for GC. Anytime, any problem, the first step would always be to look for GCF. Yeah, you follow through and you would do AC. AC is when you multiply A and you multiply C. Then you want to find the factors of AC that give you B. And then the third thing you want to do is divide by A, and I'll clarify that in a minute. So let's look at the first example here. So the first thing you would do is, again, you don't want to be looking for factors of -7. If you're doing that, that's not going to work at all. So what you want to do is AC. So it's going to be -21. So we need factors of -21. That'll give us B, -4. So the factors are going to be either -7 and 3 or -3 and 7. The one that gives us the -4 is this pair. So that's the pair we're going with. Now, the problem is a lot of students will just immediately write it as x minus 7 and x plus 3 out of habit of what we did for the B type of factoring. But, excuse me, that would be incorrect. You have to divide by A in order to finish the answer up. So A in this case is 3. So you're going to divide this by 3 and divide this by 3. If it doesn't divide, you're just going to write it as 3x minus 7. The denominator will go in front of the x, and then the constant stays there. And then if it does divide, you're just going to divide it. So this will be x plus 1. 3 divided by 3 is 1. One of the other things you need to look out for is that sometimes this can't divide, it can reduce. So let's say you had something like, I want to find something that works. Let's say we had like 8/6. In that case, these don't divide evenly, but we could reduce that to something like 4/3. Go into the factors. When it comes up, we'll go over that, but I just want that to be kept in mind. And for the last example here, again, we would do AC first. So AC for this one is going to be 40. We need factors of 40 that give us 22. That's going to be 20 and 2. All right, so that'll be x plus 20, x plus 2, but we have to divide by A. So A for this one is 5, so we're dividing by 5. 20 divided by 5 is 4, so it will be x plus 4. And 2 cannot be divided by 5. When we say cannot be, I just mean it's not a whole number. Obviously, you could do it and get a decimal. So it's going to become 5x plus 2. And that will be it. All right. The next type of factoring that you need to remember, and this one is going to be very popular, is going to be the difference of squares. When it's a difference of squares, what you should be looking for is to know it's a difference of squares. There's two terms, and one of the terms is negative. So that's how you know you have a difference. Oh, it's not automatically a difference of squares, and then they have to be squares, both of the terms. So if we look at this first example, these are both squares, x and the third squares. And when it's a difference of squares, you write it as x. You take the square root of both. It's going to be x minus 6. The square root of 6 is 6. And then it's going to be x plus 6. And again, the reason this one works out is because when you go back and you FOIL it out, the middle terms will cancel. So you just end up with the x squared to the minus 36. For this one here, I just put a coefficient just so you know you can have a coefficient here. In this case, we take the square root of 9x squared. That's going to give us 3x. The square root of 49 is 7. So it's going to be 3x plus 7 and then 3x minus 7. And it doesn't matter whether you put the minus or the plus first. It's totally up to you. All right. The next thing we want to review is operations with fractions, because again, this whole rationals is basically dealing with fractions and remembering how to add, subtract, multiply, and divide. Now, obviously, you guys have your calculator, so you could do that. But with rationals, because they're going to have fractions, because they're going to have variables in the fractions, you want to be pretty comfortable with what it requires to multiply fractions by hand, because you can't plug that into the calculator. So let's start with the first one here. The reason I picked these fractions because a quarter, hopefully everyone with logic as far as. All right, so a quarter. And then a tenth is a dime, so a dime. So you can kind of think of this as like a quarter times a dime, a quarter divided by a dime, a quarter plus a dime, a quarter minus a dime. So maybe, again, you can think of it as to what your answer would be. To me, sometimes when you think of money, it makes more sense as to why we need common denominators and things of that sense when it comes to the fractions. But when we start with multiplication and division, because those are the two easier operations, at least when it comes to fractions. So for multiplication, all you have to do for multiplication is multiply the numerator and multiply the denominator. You don't need a common denominator. You don't have to reduce. You could just straight multiply the tops, multiply the bottoms. So up top we end up with 1, and on the bottom we end up with 40. That's it. Our answer is 140. For the division, when it comes to division, hopefully remember that you cannot actually divide fractions. You have to, sorry, put a division sign. You have to change it to multiplying by the reciprocal. Multiplied by the reciprocal. So in this case, it'll be 1/4, and instead of division, it's now times, and the reciprocal of 1/10 is 10 over 1. And then once we get it to multiplication, put the dot instead of the x. Once we get it to multiplication, it's just like before, tops, bottoms. Now, one thing I do want to bring up just so you remember is that you do have an option when it comes to multiplying fractions of reducing. Let me remind you guys about that. Let's say I had something like 4 over 5 times 10 over 11 or something like that. You can, when it comes to multiplication only, you can't do it with division, you can reduce on this diagonal and make this like a 1/2. So it can make, multiplying a little bit easier if you have an opportunity to reduce. So that's pretty much going to be a major part with what we're doing with the rationals, so keep that in mind. So at this point, we don't have to. You could just multiply first and get 10 over 4, then reduce and get 5 over 2. But you could have reduced at this point and had 2 over 5 and then just multiplied and got the answer of 5 over 2. All right, so when it comes to addition and subtraction, this is when thinking of a quarter and a dime make a little bit more sense. All right, but here we go. For addition and subtraction, we need a common denominator. So I'm just going to write it for both. We need a common denominator. Because if not, this is like me saying 1/4 minus a dime. We can't just say that that's going to be, 1 dime, or it's going to change. If it's a quarter minus a dime, it's 15 cents. It goes into a complete different denominator, a complete different world. So when we're doing this, you need a common denominator. The common denominator is going to be, normally we just use the least common multiple, but if you guys want, you can always just multiply the two bottom numbers to get, so for instance, you could just say 40. That's always a safe bet to make sure you have a common denominator. But if we go with the process of using the least common multiple, the least common multiple for 4 and 10 would be 20. So I'm going to go with the LCM, and I'm going to use 20. All right, so how you complete this is we multiply 4 by 5 to get 20, so we have to do the same thing to the top. So it'll be 5/20ths plus we multiply 10 by 2 to get 20, so it will be 2. And then we go ahead and add that. When it comes to the actual addition, the denominator is the same. It's 20. Do not add that and put 4. And the numerators get added. So the answer is going to be 7/20. Let's move on to the next one. For the next one, for the subtraction. Now we don't have to go back to scratch. We can use what we already have here, our common denominators. This time I'm just going to use 40 just to show you that you would get the same answer, etc. So let's say I use 40 this time just to show you something different. So let's go with 40 minus 40. If I use 40 as my common denominator, then this would be times 10. So therefore I would have 10 on top. This would be times 4. So I would have 4 on top. Then I subtract, and my answer would be 6/40, which I could reduce to 3/20, which if I just subtracted these, I would have 3/20. All right, so that's it for the review. I know that took a while, but trust me, that's all pretty important to what we're going to be starting today, which is multiplication and division with rationals. All right, so the multiplication and division with rationals is all based on factoring and obviously knowing how to multiply and divide fractions, because that's what we're doing today. So first of all, let's make sure you know what a rational expression is. A rational expression is a ratio of two polynomial expressions. So an example of that would be something like 2x over 5. Something like x squared minus 7x plus 10 over 3x squared plus 5x, etc. It could be as simple as this, because a polynomial could just be one term. It could be as simple as the first thing here, just 2x over 5, or it could be elaborate as to binomial. It can be huge when it comes to rational expression. The first thing we're going to look at is just simplifying these rational expressions. So when it comes to simplifying rational expressions, the way we're going to do that is by completely factoring. That's the first step. Completely factor the numerator and denominator. Then we want to eliminate any common factors. Then we want to simplify. And then we want to identify any extraneous or undefined values. So let me go through this process with you. So let's begin for the first one, and let's start off by completely factoring. So with the numerator, we have the 5x already factored. What's left, this is like the b factoring that we reviewed at the beginning. We look for factors of 3 that give us 4. So this is going to be x plus 3 and x plus 1. On the bottom, we're going to have, use a different color here, the x minus 6 is already factored. And then this is the difference of schools. This is the d type of factor. So it's going to be x plus 3 and x minus 3. Again, if you can't factor, it's going to be an issue for this whole chapter. So you really want to go back, review your factoring, and just make sure that's pretty strong. The main types will be, again, a DCF or a 1 and the difference of schools. So once you have it to this point where you factors anywhere in the top. Step 1 is done. You want to eliminate any common factors. So top and bottom, and by eliminating, we like basically reduce. Like if we have 2x over 2y, we could cross out the 2's. So that's what I mean by eliminate here. So anything we can eliminate would be in this case, x plus 3. So what's left is going to be 5x plus 1. And then on the bottom we have x minus 6, x minus 3. And this will be our final answer here. Simplify. That's all we can do. This is, you don't want to go back and multiply it back out. That's not necessary. That will be it. The one thing that you will need to do is to identify any extraneous or undefined values. So extraneous are values. These are values that will make the expression undefined. I don't know why I wrote that up there. Undefined. I can put it over here. I think. Undefined. Now, what this means, basically, when it comes to what we're dealing with now with the rational expressions, is that the denominator cannot be 0. So that's always been the case since the very beginning of fractions. When we first started, the denominator cannot be 0. So basically, any extraneous just means it works for the solution, but it's undefined. In this case, it's really not extraneous. Because that's when you actually like solve an equation. So it's really not extraneous, but it's undefined values. The values that'll make the expression like not possible. So the values that are going to make the expressions not possible will be anything that would make the denominator 0. So the undefined values or extraneous values would be anything that would make the bottom 0. So in this case, it would be 6. And technically, you would do x minus 6 equals 0. This would be negative 3. And this would be plus 3. And again, take any of these bottom factors and set them equal to 0 because that's what would make it not work. Alright, so those would be your undefined values. If those were one of the answers, you couldn't put it in, it wouldn't plug in, it wouldn't work, it'll be undefined. All right, let's look at the next one. Example 2. Same thing we want to do here is completely factor. Top is already completely factored, so I'm just going to rewrite that. We have 4y, y minus 3, y plus 4. The denominator is y. This is a regular, just c factoring. So it's going to be x minus 3. Y minus 3. If I do that throughout, my bad, I tend to always put x. So that happens a lot with me. Oops, and there I go again. Y. All right, so y plus 2 and y minus 3. Again, I need this to give me a negative 1 in the middle. So that's going to be the factoring. So once I have everything factored, I'm going to cross out what I can. What I can cross out this time is going to be my y minus 3's. And I can also cross out the y from the outside there. So what's going to be left as my answer for this is going to be 4, y plus 4. And in the denominator, I just have y plus 2. I don't need the parentheses at the bottom, just have it, so I'll keep them there. Not wrong to have them. That's my answer. But again, I want to get in the habit of knowing what the undefined values are. I won't necessarily ask you every single question, what are the undefineds, etc. But you want to keep that in mind of just knowing what they are and knowing how you would find them. So when you are required to write them out, or if you're asked, is this a solution, you'll know why or why not something will work. So again, we look at the denominator, even the things that are eliminated. So the first thing, it can't be a 0, because if this was 0, it wouldn't work. The next one will be if y minus 3 is equal to 0. And the next one will be if y plus 2 is equal to 0. So there's going to be 3 and negative 2. Those are my undefined values. All right, I'm going to keep it moving. I'm already getting kind of long with this video, so I would pause it now, guys. Try the next two examples here, examples 3 and 4 on your own, and then unpause it and see if you got them correct. So again, hopefully you paused the video, and here's examples 3 and 4, the answers. Check them out. If you have any questions, again, feel free to come into the meeting space and ask me anything you need. I'm going to move it down now to examples 5 and 6. Examples 5 and 6 are a little bit different, so I want to go through those, and then we'll go to the multiplication and division. All right, so for the first example here, example 5, actually 5 and 6 aren't too much different. I'll do 5, and then I'll skip to 7 and 8 are the ones that are a little different. For example 5, we'll factor out the top, so we have our x squared, and then we have x minus 7, x plus 2. Again, I need negative 14, and I need negative 5. The bottom, I have x, and then I have x plus 4, x plus 2, get 8, and get 6. Now I can cross out anything that's a common factor. So I can cross out my x plus 2's. And on the outside here, I can't cross out the full x squared, but I can cross out one of the x's. So I'll just be left with x, not x squared anymore. Alright, so up top I'll have x times x minus 7. On the bottom I have 4 times x plus 4. That's my answer. And my x is not equal to 0. It can't be 0 there. It's not negative 4. And it's not negative 2. All right. So give example 6 a try, and then we'll move on and do one of the last two together. All right. So here's number 6. Again, hopefully you guys are getting pretty comfortable with it. Let's go to number 7. So number 7 and 8 are a little different in the end, and I'll explain to you why. If we look at the top here for number 7, we can take out a GCF from the top. We can take out a Z. So I'm going to take the Z out. And once we take out the Z, we're left with x minus 4. For the bottom, it's already factored. So we have Z squared, and we have 4 minus x. Now, this is what we call, if we look at this, they're slightly different. Let's see if this will work. Oops, not highlighting what I want to. So they're slightly different with what is the result of this and this. What's different is that the x is positive here, the 4 is negative. The 4 is positive, the x is negative. What we call these are kind of like opposites, because it's like a positive one and a negative one, etc. Because these are opposites. So when we have something like this, we can eliminate them. But instead of getting like 1, which is what we get if we have x plus 4, x minus 4, I'm sorry, x plus 4, if we cross those out, we just get like a 1. If they're opposites as they are here, we're going to get a negative 1. So when we cross this out, we're going to have to acknowledge that and put like a minus 1 in that spot whenever they're opposites like that. And that's going to be when both of the sides are, be careful because like, x plus 4, x minus 4, and they think they can cross that out and say negative 1. That is very incorrect. That's not right at all. So can't do that. It has to be a complete switch. Like both of the items have not just the plus minus situation. It has to be a complete change. Like both numbers are different signs. And when that's the case, again, we can cross them out and put a negative 1. Now, the other thing that can be eliminated here, we still have the z's on the outside. So this z, we'll take out the x squared. So we'll actually just end up with an answer here of negative z. Actually, I'm sorry, the z's on the bottom. Sorry. So negative 1 over z. Sorry. I thought it was up top. All right, example 8 is kind of similar, so let's work on that. We're going to have a negative as well here. So let's see how to approach that. So for the top one, we can take out a GCF of AB. Let's see if that'll work. AB. And we're left with B minus 5. Then on the bottom, we can do a difference of squares. Now, it might not look like a difference of squares because the variable's second, but the variable can also be the thing that changes signs with the plus minus. But this is a square, this is a square, so that's a difference of squares. And now if we look at it, again, this is when you can do it, when both things are, it's like a complete reversal. Like this is a positive, this is a negative, this is a negative, this is a positive. Both elements have to have different signs. So it's like a complete reverse. And once we have that, we can cross them out, but we have to replace it again with a -1, not just a 1. So our answer here would be, you can put the negative AB. You can just stick the negative in front like that. Doesn't matter however you want to write these things. It's up to you. But you know, whatever you're comfortable with, it doesn't matter where the negative goes as long as you acknowledge that there is a negative. And for these last two, I forgot to put the extraneous values. Same thing here. Z would not be 0. I'm sorry, I put in X here. I guess I meant that. And X would not be 4. And for this one over here, B is not 5. We can put plus or minus 5. B can't be plus or minus 5. All right, so I'm going to move on. And we'll start with the multiplication and the division. So for multiplying and dividing these rational expressions, oh my gosh, I'm sorry, this video is going to be really long. So for multiplying and dividing these rational expressions, first thing you want to do is the same as with the simplifying, is completely factor everything we can. And basically the only thing we're going to add here is that the simplifying is going to include the multiplication. Should have written that, but the simplifying step is not only just going to be reducing it, we're going to be actually multiplying the two fractions in that step as well. But so if we look at example 1 here, first thing I want to do is factor. These are just kind of GCF factoring, so let's see what we can do. It's nothing really to get out. Yeah, we don't need to take anything out. What we can. So if we look at on the diagonal here, remember that when we first started with the fractions, you can reduce on the diagonal. So I'm going to look at the 8 and the 6 and the 8a. I can cross out the 2 from both to be a 3, and this will be a 4a. I can also reduce on the other diagonal. I can cross out the 5 and make this a 1 and make this a 3. And then the d can go here, and that'll make the d squared go away. And then I can go ahead and multiply. So right now, let me write this before I actually multiply. I have 3c over 1 times 3cd over 4. Essentially, that's what I multiply. At the top here, remember when I multiply numerators and I multiply denominators. So I'm going to have 9 squared over 4a. Now we still have restrictions. This would still be d is not equal to 0 and a is not equal to 0. Because those would make the denominator 0 and they get so again, you don't have to list them every single time, but you do want to know, you know, when you need to, if I ask you if something's a solution. So always keep them in mind, but it's not a requirement to list them every single time. For example 2, that one's similar. We can, you guys can try that one on your own. Try numbers 2 and 3 on your own, and then we'll move to 4 together. So pause the video, try 2 and 3, and then we'll do 4. You know what? I'll do 2. Change my mind. I'll do 2 with you guys. So for this one, I can go again on the diagonal. So I'm going to look at the 21 and the 14. I know 7 goes into those. So this is 3. This is 2. I have an A here. I have an A here. The A is gone. The A squared is now gone. The B is gone from here. The B is gone from here. All right. On the other diagonal, let me use a different color. I have 12 and I have 8. So I know 4 goes into this 3 times. 4 goes into this 2 times. C to the third divided by C squared. That's gone. This is just C to the first now. This is gone. This is just D to the first now. So again, what I have is 3CD, just so you're clear, over 3. Everything else is gone from down here. Times, that equals 2A over 2. Now I wasn't even paying attention. Didn't have to rewrite that. But these 3's could go as well, and these 2's can go. So essentially I have CD times A. So my answer is just ACD. We normally put them in alphabetical order. And again, don't forget what would be considered extraneous here. Can't really even see what I crossed out, but I think it's A is not equal to 0, B is not equal to 0, C is not equal to 0, and D is not equal to 0. All right, so try 3 on your own, and then we'll do 4 together. Okay, so hopefully you guys tried example 3, and that is my answer for 3. And I'm going to move on to 4. So for 4, 4 is going to be where it starts to get a little bit more elevated in level of difficulty. So something like number 4, again, if we go back to the steps, the first thing we want to do is factor everything we can. So I'm just going to go ahead and start off by doing that. For this first one, for 16, in order to get negative 16, it's going to be x minus 8 and x plus 2. My denominator is going to be x minus 8 twice. Here is going to be x minus 8. Bottom is going to be x plus 3 and x plus 2. Again, the working with the factoring will take a little bit of time for you guys to get a little faster, but hopefully it's in you and it's not, too difficult. I mean, hopefully, the concept is in you. It might take you a little bit more time than me, but again, as long as you know how to factor, that's the main thing. All right, so now after we have it completely factored, we cross out anything that's a common factor, that we can reduce out, basically. So I can get rid of these x minus 8s. I can get rid of these x minus 8s. Because remember, I can reduce on the diagonal. I can get rid of these x minus 2s. So what's left? It's not 0 on the top. When I'm reducing things, it's a 1, essentially. So it's a 1 here, it's a 1 here, it's a 1 here. So my answer is just going to be 1 over x plus 3. Now again, if I was asked for undefined values or extraneous things that wouldn't work, it would be x is not equal to 8, negative 3, or negative 2. All right, I'm going to move on. I'll do example 5, and I'll leave you guys to try 6 on your own. So for example 5, I'm going to factor it. Excuse me. All right, so for the top, 8 and 20, I know I can take a 4 out. Minus 5. The bottom, I have x minus 5. X plus 5. X minus, sorry. In order to get a minus 7, I have to have a minus 2 and a minus 5. And on the bottom here, I could take out a GCF first. Let's do that. It'll be x plus 2, x minus 2. Again, if I just take out a 4, it will be for the bottom here. It'll be x squared plus 4. That's why I have what I have here. So let's see if I have anything that can be reduced. Here, it doesn't look like I have anything but this. All right, so it looks like all I have are these that I can get rid of. Let me double check. Minus, minus. Yes, it all looks good. So unfortunately, I can't cross out anything else. So once I cross out the only thing I can, now again, you want to avoid, don't think you can cross these two out. That's a common mistake. It has to be the X's changing signs and the 5's changing signs. The way this is, they cannot be crossed out. So my answer here is going to be 4, 2x minus 5, x minus 5, over, oh, I could have crossed out the 4's, I'm sorry. Let's do that. So erase, you go away. All right, over x minus 7, x plus 5, x plus 2. And that would be my answer. Have to multiply it back out. You're done at that point. Again, don't be alarmed. Don't think that everything has to cross out. I wanted to make sure I did one where you guys weren't like, oh, I have too many terms left. Again, it can be something where you only have one or two things cross out. I'm just going to write my extraneous values here just so I'm aware of what they are. So it would be undefined if x was 7, negative 5, negative 2. I'll put plus or minus. Plus or minus 2. All right, so pause the video, try number 6, guys. All right, so for this last one, I end up with an answer of -1 for example 6 once I crossed everything out and eliminated everything I could. All right, so I'll try to go a little faster through the division. For the division of the rational exponents, basically the process is going to be the same. The only difference is that when we divide, we went over this in the beginning, if I had 2/3 divided by 1/2, this would have to change to 2/3 times 2/1. You multiply by the reciprocal, and you would get 4/3, etc. for your answer. So that's the key thing that's going to change, but the process of factoring and crossing out and everything else is the same. So let's just rewrite this as a multiplication problem. 18xy cubed over 7a squared b squared times 35a squared b over 12x squared y. All right, so once it's rewritten, then you can go ahead and eliminate like we do on the diagonal, up, down, whatever way you can. So I'm going to go on the diagonal here. This is 1, this is 5. A squared will cancel. The b will take away the b squared. 12 and 18, this is 2, this is 3. They can both be divided by 6. This x is gone, and this is x to the first. This y is gone, this is now y to the second. So it's going to be divided. This would have been 3y squared over b times 5 over 2x. So up top here we have 15y squared over 2x. That would be my answer. And again, keep in mind what would be undefined values, etc. So I'm going to skip example 2. You guys can give that one a try. I'll post all the answers later, but you guys can give number 2 a try. Okay, so here are answers for 2 and 3. Hopefully you guys are able to follow that through. Again, it's pretty much the same as we did previously, but the multiplication, you just have to do the first step of the reciprocal. All right, so let's move on to example 4. Example 4, before we do any factoring, I want to just go ahead and rewrite it so I won't forget to do the reciprocal. So it'll be x squared minus 16. Actually, I'm just going to write it over here so I can save some space. So it'll be x squared minus 16 over 12y plus 36 times y squared minus 3y minus 18 over minus 12x plus 32. Now, again, if you're comfortable just doing it in one step and not having to rewrite it, that's perfectly fine. The same with the previous things, like you don't necessarily have to rewrite this or this. Sometimes I just find it gets a little messy when we cross everything out. We don't know what's left. So that's why I just wanted to rewrite it for you guys. All right, so let's move on. So for the next example here, I'm going to factor. So I'm going to have x plus 4x minus 4. It's a difference of squares. Up top, in the denominator, I can take out a 12. And then it'll be y plus 3. On top, I have y. It's going to be plus 6 and y minus 3. Actually, other way around, sorry. Minus 6 plus 3. Then on the bottom here, I'm going to have x 32 has to be 8 and 4. So x minus 4, x minus 8. All right, so now let's see what I can get rid of. I can get rid of an x minus 4. I can get rid of a y plus 3. And that's it. So I'm going to be left with x plus 4, y minus 6 over 12, x minus 8. And again, keep in mind what would be considered extraneous values would be, well, not extraneous, undefined. Y can't be negative 3. X can't be 4. X can't be 8. And the reason I wanted to do this, when it comes to division, you have to consider any time it was a denominator. So it would actually apply to this denominator here, and this, because now this is the denominator. So if at any time any of this would have been 0, it would say undefined. So you just want to keep that in mind. So where was I? So then the other one would be the other things that wouldn't work would have been up here. So y can't be 6, and I already had the negative 3. Okay. All right, so this is my answer. All right, so let's move on. Do one or two more divisions. Actually, I'm gonna move. Let's do. I guess I'll do one more division here, then I'll do a complex, and then we'll call it a day. Sorry this video was so long. I had to go back and review some factoring stuff. So for example 5, it's going to be x minus 5, x minus 4, x plus 7, x plus 3. I didn't do this first, but I'm going to do it in one step. Just keep my time. This will be 6, x minus x plus 7. The denominator will be x minus 4, x plus 3. So what I can cross out will be my x plus 7, my x minus 4, and that's it. So I'm going to be left with 6 x minus 5. And whenever we have the same thing, x plus square. That always be the way you guys should write that. That would be the simplest form. All right, so try number 6 on your own. Give it a try. See what you guys get. All right, so here are the final answers for example 6. All right. So the last thing I want to do is just at least one of these problems dealing with simplifying complex fractions. So in order to do that, I just want you to know what a complex fraction is. A complex fraction is basically if you had something like, well, this is a regular fraction. Let's say you have something like 2/3 over 1/4. So this is an example of a complex fraction. So by that, it just means it's like a fraction of a fraction. So this would convert to be 2/3, the top number staying the same. And it's being divided by 1/4 because it's 2/3 divided by 1/4. Then I would rewrite this as 2/3 times 4/1 because I can't divide. Multiply by the reciprocal. And that's how I get my 8/3. So when it comes to the complex fractions, again, that wasn't complex, that was just regular fractions. But when it's complex and we're dealing with these rationals, it's gonna look pretty extra. It'll be something like the following. So instead of being natural, it'll be like 2x over y. Then all of that is over 2. Be two fractions again, but both of them will have, rational expressions and everything pretty much. So again, you would convert this. The first one will say the same, and you're dividing that by x over 2. Rewrite it as multiplication, and then you would follow the process for multiplication as we have been throughout. So let's do the harder of the two, example 2, and then I'll leave you guys with the examples I'm attaching for you to do some extra practice. So what we want to do here is just write it as division. So if we look at example 2, the harder of the two here, let's just rewrite this as division instead of this elaborate fraction. So again, this is the top fraction, this is the bottom fraction. So we have x minus 2 squared over 2x squared minus 5x plus 4. Now I'm not doing any factoring or anything at this point. I'm just rewriting it. If you want to save some time and try to do it in one step, that's fine. I just want to be clear on the steps that I'm following. All right. So this would be the initial separating of the complex fraction. So now it's just a regular division. Now we need to rewrite it, so it's not division, it's multiplication. So let's do that. It'll be x minus 2 squared over 2 times, all right, so that would be what it would look like now that we have multiplication. And now let's go ahead and factor and solve this thing. So I'm just going to rewrite this twice just so we know what this means. X minus 2 squared means we have that twice. X minus 4, x minus 1. That's how we'll get a minus 5 and a plus 4. Up top we have 4, x minus 5. I'm sorry, x minus 2. Oh, I'm sorry, why did I say that? Can't do that. It's going to be 2 x minus 5, 2x. Sorry, 2x minus 5. And then down here we'll have x plus 2x minus 2. All right, so let's see what I can eliminate. I can get rid of an x minus 2. I can get rid of a 2. And that's all I got. Let me just make sure I got my signs right. Yeah, that's all I got. All right, so everything else would be, just going to write it down here, x minus 2, 2x minus 5. All right, that would be my answer for this complex fraction. And I don't feel like writing the extraneous, but there'll be a couple values, that don't work. All right, so like I said, try some of the practice problems. I'll post all of the answers. Sorry, this video is so long. Have a good day.